currently work. I guess the thing that now we've talked about data a lot. I guess now it would be the perfect time to ask you that nowadays that in our data there are lots of biases, right? Inbuilt biases, inherent biases. I mean, there have been reports that people, cameras are like more likely to I don't know, claim a black person to be a criminal, something like that. And
Mm-hmm.
not necessarily that person could be criminal, but it's just that the data. I mean, the model has learned from our inherent biases, and the model doesn't know what it is, and it will just learn. It's just like a so my question would be how to mitigate these biases in AI models if the model is learning from the data and we as human beings are like, sort of imperfect. And how do we make more rational AI models? Your thoughts?
Yeah, so I'd start with an example first to help people understand what we exactly try to mean by bias here. For example, Reuters published this report on Amazon hiring portal earlier, long back, but so it had it had an inherent discriminatory bias against women profiles. So it was talked way longer in the news that the algorithm would discriminate male candidate profiles to be more suitable for certain kinds of jobs than female ranked profiles, right? So that is certain kinds of biases. And the other example that you also gave is about the race, right? So being able to have such fair algorithms to be able to do that. So to prevent bias, there are a couple of methods that we typically employ. Primarily, one of them being started at root. So there are a couple of methods in being able to understand what exactly is the model trying to predict. So one of them is Lime and SHAP. That helps you understand what exactly the model is trying to interpret. So Lime is nothing but local interpretable model agnostic explanations. So it is gifted with highly interpretable linear or tree based models to be able to predict the predictions of being tested for bias. So for instance, like deep convolution neural networks for like that are used for image recognition are really very powerful, but they are not very interpretable, right? So human decision makers can review the decisions from these models. What exactly are they focusing upon? So these libraries help you understand whether the intent of the focus, what you wanted to train upon, is exactly serving the purpose or not. And you can directly eliminate such variables from source. You don't need to always go around that, hey, do I want the most accurate information? Because as data scientists, as data practitioners, we are always under the constant pressure of thinking that, hey, this has to be 99.99% correct, or it has to increase in terms of accuracy. But we would also want to consider the fact that, hey, whether with that accuracy or with those levels, am I introducing some inherent bias that is not impactful for the long run? So try to look for such variables that are directly impacting this particular thing, and they cannot they should be cut at source. That is one of the methods that I would say.
So, as given the best example out there, which was there in the news, one more example which I heard was this face detection algorithm, right? And how there's been trained, and there was a kind of biases which was there, especially for the women in black, right? The accuracy for the model was having almost 98%, 98% for the people of white color, and it was having a very low accuracy for the black people, or maybe uh, especially for women in black, right? So now these kinds of algorithm will be when they will be in you can say in ground, right? They can create a lot of problem, and they could, and this is not only because of the only with the data, the how the we even humans have been biases towards a lot of things, and that is the major problem. And especially if you look, especially if you look about now, especially in healthcare, I talk about more because if you look, right, if one radiologist is trying to do something, right, you want to predict the tumor is there, there could be 10 different radiologists who will be trying to provide the ground truth for the same kind of data in 10 different ways. There could be. Now, if you think like if I'll give that kind of data to the model, the biases is inherently in the way I'm providing it to the model. So that's a very crucial part. How will we be able to mitigate those issues? So yeah, that's a bigger problem. And as I think right now, last 10 minutes talk by Andrew MG was that same thing that we have to be more data centric, not model centric. So the better we can clean up the data, provide the best kind of data to the model, majority of our time, or you can say the majority of our work, is going to be covered in that stage. We will not have to be focusing, create a like more complex model and getting into that phase. The better we can create the data into a much balanced, or you can say clean up way, we'll be able to solve the problems in much better way. So yeah, obviously the solution is more towards how we are creating the data and providing it to the model part. If we can mitigate these things, yeah, as you rightly mentioned about the explainable AI tools which we have right now, like Lime, I've not explored them more, but yeah, I've heard of them and they are pretty good. And especially for the medical imaging, you see GradCam and other kind of thing where you can visualize actually why the model is behaving like that. So you get some, it's not only a black box kind of thing, you get some intuitions why, what is the reason behind that particular thing. And another thing is this fair AI part that is also kind of being initiated by Microsoft also, and IBM have their like some APIs where you can understand or divide the data into a fair way. These using these APIs, so before even giving it to the model, you can look at the data and you can see how it will behave. So I think these are the some new tools or very research oriented tools right now. It's not in something which is very common. People are just exploring it at that level. So surely I think there is a lot of work in those spaces which could be helpful for yeah, future.
Sorry to interrupt. We have with us our next panelist. She is Dr. Tapti Bandyopadhyay. She has spent more than 25 years of her professional and leadership career as a hands-on AI builder, inventor, researcher, and practitioner. She partnered with senior AI automation SMEs from Gartner and Wipro to establish the first ever AI automation focused practice research and IP organization, AISwitch.org. Ma'am had been a DFID scholar at Strathclyde and holds a PhD in AI, as well as she has a university gold medal in engineering. Welcome to the session, ma'am. We are excited to have you with us today.
Thank you, and glad to be here. I was just silently listening to the other panelists, and can you hear me? Am I audible?
Yeah, yeah, you're audible.
Great, great. So I was a bit late to join, but whatever little I have heard of the discussion, I am feeling even better to be able to join it late. Sorry for being late, but at least better late than never. So I think taking the discussion forward as per the theme is concerned, in terms of like probably exactly what my previous speaker was talking about in terms of explainability, this is exactly the area that have been my kind of focus for quite some time now. In fact, since I joined Wipro, so in Wipro, in fact, I set up their home AI automation ecosystem practice. And as a part of that, I was working very closely with the Microsofts and AWSs and Googles of the world, because we were basically building use cases with their APIs, right? So the good part about the Googles and AWSs of the world is that they sit on top of huge volumes of data about you and me, and they also sit on top of fantastic compute power and AI algorithms, right? But unfortunately, they don't have the context, and that is where specific business cases, the problems of the clients, that is something which the service providers and system integrator industries, they always have much more than these pure tech companies, right? So that is where, in fact, the Wipros, Infosys, and TCSs and Accentures of the world come in. And in that capacity, in fact, I set up their partner ecosystem and a lot of evaluation. For example, I remember we were the beta side of Amazon AWS SageMaker and Sumerian in the Google engineering, in the Homes engineering team. Then even for Intel and Nvidia, we were given their sandboxes at a very early stage to run some of our use cases built on top of the AWS algorithms and the Google Dialogflow kind of stuff at the early days. But explainability actually was a challenge given to us by some of our Wipro, as you all know, is very strong in the BFSI space. So is Accenture and IBM and other folks. And essentially, in BFSI, the adoption of AI is so far the highest, right? Compared to the other, like in manufacturing, the allied sectors are very much on the uptake, like the IoT or Industry 4.0 kind of spaces. But if you see pure play AI algorithms and use cases built up on AI algorithms, like know your customer kind of use cases, or in case of insurance, the claims fraud detection kind of use cases. So those are very mature AI use cases in the BFSI space, in the end user industries across all segments. So in BFSI space, a lot of our clients in Wipro, very large US and European banks and insurance companies were working with us to build these solutions, and they actually gave us the problem of explainability. So a simple example: when you call an insurance claim potentially fraud or incomplete, there is some anomaly in the claim, right? Now, typically, these are all customer facing applications, or even in KYC, if you say that, there are things that are not explained in terms of why are you calling my KYC incomplete, what's the problem with this data that I submitted, and things like that. So these are all customer facing apps, and customers have every right and every reason to question anything that AI generates, right, as a response. When the funny part is, when human customer service agents were doing it, then customers were totally happy, right? I mean, if a human agent goes and tells the customers that, okay, we couldn't read your this particular document submitted, the quality of submission is poor, then the customer was happy and share, they would gladly share maybe another clearer picture of their other god or something. But when the AI agents are doing it, then the customers have all problems of explanations of the world, essentially. And we can't blame the customers, right? Customers are the kings for our clients. They are our customers. So essentially, whatever questions they ask, we have to answer them. So that is when, in fact, we started building the explainability solutions. And we did a simple thing for every text-based kind of a response, like for chat, for typical customer service, like when KYC incomplete kind of messages are going through chat. So we had to integrate the chat output with an explainability layer. So what we did is and explainability in computer vision is still okay, because say for example claims fraud detection, you can say that, okay, these are the features which are which are not looking authentic, and this is why we are calling your claim as invalid. But in case of text, it's extremely difficult, because you cannot say that on the basis of this social media feedback, we are telling that your KYC document doesn't look authentic, right? So that is where, in fact, what we did is we actually put this algorithm called LRP, layer-wise relevant propagation, in front of the output of LSTM. So we were using LSTM to extract text and fill in the forms. And then filling the forms, of course, can be done by any so-called stupid API from an RPA. But the extraction, the semantic extraction, we were using LSTM, and then we put the output of LSTM go through the LRP layer. And that is where, in fact, we took some 3 patents, US patents, on how to use Xi on text. And the use cases were right in front of us, and we demonstrated them to the US banking clients and one big corporation, insurance corporation in EU. So they were pretty happy. And some of the US customers, the banking customers, like Capital One, for example, they already had explainability built into their systems from 2016. In fact, many of us were very pleasantly surprised to see that Capital One had a XAI COE, an explainable AI COE, as part of their AI COE from 2016. So very, very early thinkers, and they were already doing some stuff in the computer vision use cases, but not so much in text spaces. So we learned a lot from some of our clients and built some XAI solutions together. So this is one area which is probably going to be huge in this particular decade, in 2020 onwards. And I think all of us AI practitioners, and this is actually in US banking, as far as I know, for all the large banks. In fact, XAI has become regulatorily mandatory, right? So anything that you expose to your customers, or anywhere you are using customers data, you should be able to explain to the customer why are you calling a customer transaction invalid, or why are you using a customer data to recommend certain things to customers. And explainability will be everywhere, in fact, not just in BFSI, but in retail, in manufacturing, in fact, even in Amazon's kind of space, when you are using recommendation engines, there has to be a layer on why you are recommending certain products to certain user groups or customers, and that's coming, and that will become a mandatory regulatory requirement going forward. It already is in some sectors. It will become more pervasive in all other sectors. So I think this discussion is extremely timely, and all of us AI researchers and probably practitioners, we need to build more IPs. Sorry, my German Shepherd is making a ruckus downstairs. Somebody must have come. But yeah, he doesn't require artificial intelligence. We do. So some anomaly he must have detected. So, but the best part is, so long as we cannot tap in their intelligence, we have to rely on our own intelligence and AI. And for that, explainability is going to become a huge requirement going forward. And I'm very happy that we are, taking these discussions in IEEE forums in the right direction. And going forward, it will remain so.
Yeah. Also, I wanted to add to one of two more points I wanted to add. One of them being able to improve diversity. So I was just looking up another article, and it talked about, apart from explainability, it talked about why the biases creep in, and who are the folks that uncover such biases. It's not always the end users. It at times, most times, that are the end users, but also the model builders or the algorithm builders or the data collectors or the data scientists. They also are there. So that stat talked about that most such biases are there in during the training phases itself, and they can be directed or cut short uh, if they are notified to the right. They are first noticed. These issues are 40 to 50% of the times first noticed by female or people of color against the folks for which this bias has already crept in. So
True.
when I read that, I was like just wondering about the fact that if we have that more inclusive, more open, more diverse culture in terms of the teams that build this product, uh, it like these things can be cut at source, both in terms of demographics, both in terms of skill sets. It is important to mitigate such unwanted biases, and we are not here to pay anyone lip service that hey, that these folks should be there. It is just in the interest of that particular article that I read, that hey, if these folks are themselves able to able to inspect or detect that hey, this is pretty unfair, because as guys working in this particular domain, or as folks of not non-color, we might be not able to detect this, right? So we would want to have a more inclusive, more diverse workplace where folks of different opinions, races, backgrounds can come in and contribute to such things. And to also add to my second point, which is what Ashish was mentioning around having tools that can mitigate that. So IBM also does has such debiasing tools, and they have an AI fairness project also to
Yes.
right.
AI
So
360. Yeah.
correct. So they have this AI
Yes.
fairness 360 library that has about 10 debiasing approaches. So
And it's open source. Cheers.
exactly. Yeah, totally. So AIF 360, I just wanted to bring that up as a concrete example to the listeners, to the students who would be uh, building their first niche ML model. So I would recommend that you could use that. It can be applied to a host of model ranges, ranging from simplest classifiers to deep neural networks. Some of them are pre-processing algorithms which aim to balance the data itself. Then there would be some of them would be in processing algorithms, and they intend to penalize the unwanted bias during the model building phase. And then there are certain elements in this same library which are around the post processing bits that intend to balance the favorable outcomes after a prediction has been made. So these are two other points that I wanted to add when it comes to debiasing tools for whenever bias has crept in into your models.
And
Wow.
also, probably to add to that point, in terms of, for example, for builders, SageMaker has got an extension of bias mitigation in ML models called Clarify. I think that's the name of. It's a recently
Yeah.
added library, and I don't think it's completely open source, but for AWS users, it should be easily accessible. But another challenge, in fact, it is again, a very good discussion for builders, like AI 360 being an open source library. But in context of real world applications, it's a very difficult challenge. I'll give you a simple example. Again, going back to the banking area. So we were building something for loan processing, right? So loan eligibility prediction models. And it's that again is a very common use case, right? So there, in fact, what was found by some of the Indian clients was that the many women were actually being a kind of given very negative loan creditworthiness ratings. And despite the fact that gender as an attribute, as a parameter, was dropped, it was masked actually, even in the model. So
Yeah.
then we tried to figure out that why is it that even if we are not using gender as a model attribute, even then the model is biased against women. And interestingly, we found out that you are talking about why is so important to get business users feedback on these things. We found out that the quality of collaterals for women loan applicants is very poor, especially in India, given the fact that even though in Hindu property bills and all that, now legally girls and boys have 50% rights, to same rights to the ancestral properties. In practicality, what happens is the girls always forego the rights in favor of their brothers, right? And in that case, what happens, there are very little properties that are registered in the names of women, which
Yeah.
is why when these women go for loan applications, the quality of collaterals is very poor because they don't have any properties in their primary names. And that's one of the reasons why the bias was getting there into the loan application. That is why it is one thing to detect that yes, there is a bias, which is something that thanks to AI 360 or Clarify kind of models, AI itself will probably tell that the number of women being discriminated is much more than men. And but to be able to detect the root cause of a bias in a model, it is extremely important for builders to work extremely closely with the domain experts or process owners who had been running that process in the business side of it for donkey's years, right? Because they actually helped us figure out that this is nothing to do with the rest of the customer attributes. And I mean, no AI engine in the world could figure out that collaterals can be a problem and a root cause of discrimination from the data source.